Hi guys, I'm Dr. Nandabalaji. Today we are discuss about the topic of quantum mechanics, the Planck's theory and derivation method. First of all, we discuss about the black body radiation. In the previous topics, recap of the black body radiation. In this black body radiation, delving into Planck's groundbreaking work, let us briefly revisit the concept of black body radiation. What precisely con- constitutes an ideal black body of the work nature? These are the so, shown in the last video. What mechanism dictates its complete absorption of all incident radiation, and what fundamental parameters does the black body spectrum inherently relay? What compelling in imperative necessities a novel theoretical framework of explaining high frequency radiations. And first of all, we are introduced the Planck's quantum hypothesis method. In maximum of Planck's revolutionized physics with a radical proportion, energy is not continuous but discretized into finite packets. Planck posited that the energy exchanged by oscillators in cavity walls is quantized following the relations E of n is equal to nh divided by nu. This conceptualization suggests that energy is absorbed or emitted only in integer multiple of a fundamental unit like as h by nu. The hypothesis laid the foundational cornerstone for the entirety of quantum theory, marking a profound departure from classical physics. Core assumptions underpinning Planck's theory, like as Planck's innovations theory, was constructed upon several key assumptions that diverged significantly from classical understanding. Electromagnetic radiation within the cavity is modeled as an ensemble of harmonic oscillators. Crucially, these oscillators emit or absorb energy exclusively in discrete quanta, not continuously. The statistical distribution of energy among these oscillators adheres to principle of statistical mechanics. The spectral energy density is fundamentally determined by the density of available electromagnetic modes. In the derivation steps of average energy per oscillators, this crucial step determines the average energy associated with each oscillator, departing from classical partitions. Employing the Boltzmann distribution, the average energy per oscillator is calculated E is equal to summation of n is equal to 0 to infinity nh mu e power minus nh mu by kt divided by epsilon n is equal to 0 to infinity e power minus nh mu by kt. Upon evaluating this summation, the expression for the average energy per oscillator becomes h mu divided by e power h mu by kt minus 1. Derivation steps of 3. The Planck's radiation law. By synthesizing the density of states with the average energy per oscillator, Planck formulated his revolutionary radiation law. Combining the density of states with the average energy per oscillator yields the energy density expression U of mu by mu t into d mu it's equal to 8 pi h mu cube divided by c cube 1 divided by e power h mu by kt minus 1 into d mu. This profound equation stands as the definitive Planck radiation law, accurately describing the black body spectrum across all frequencies. Resolving the ultraviolet catastrophe. Planck's quantization hypothesis provide a precious resolving to the long-standing problem of the ultraviolet catastrophe. The classical Rayleigh Jeans law enormously predicted an infinite energy output at high frequencies, a phenomenon dubbed the ultraviolet catastrophe. The introduction of energy quantization by Planck inherently incorporates an exponential suppression T, preventing this classical divergence. Crucially, Planck's law demonstrated remarkable agreement with experimental observations across the entire electromagnetic spectrum. Analysis of limiting cases examining the Planck's radiation law in its limiting cases reveals its compatibility with the earlier empirical law. Low frequency remains H by Nu or IIKT. In low frequency limit, Planck's law simplifies to the Rayleigh-Jeans law U of V mu t it's nearly equal to 8 pi mu square kt by CQ. High frequency, conventionally the high frequency limit it converges to Wien's approximation u of mu by mu t. It's directly proportional to v cube e power minus h mu by kt. Profound significance of Planck's derivation. Planck's groundbreaking derivation extended far beyond resolving the blackbody problem in inaugurated a new era in physics. Birth of quantum mechanism 1900 marked the foundational genesis of quantum mechanics, challenging classical determination. Discrete energy levels introduced the revolutionary concept of discrete energy levels within physical systems, enabled Einstein's photoelectric explanation, provided the theoretical underpinning for Albert Einstein's seminal explanation of the photoelectric effect. Foundation of modern statistical quantum physics established during bedrock for the development of modern statistical quantum physics and its